Hello everyone, it's September 23rd. Alright, let's do this. We still need to figure this one out. Alright, find the length of the longest common prefix. Find the length of the longest common prefix. You're given two arrays with positive integers. A prefix of a positive integer is an integer formed by one or more of its digits. A prefix of a positive integer is an integer formed by one or more of its digits. Starting from its leftmost digit, for example, 1, 2, 3 is a prefix of the integer and 2, 3, 4 is not. A common prefix of two integers, a and b, is an integer c such that c is a prefix of both a and b. For example, these two have a common prefix of 5, 6, 5 and 5, 6, 5, 5, right? 1, 2, 3, 1, 2, 2, 3, and do not have a common prefix. Okay, you need to find the length of the longest common prefix between two pairs, between all pairs of integers, such that x belongs to array 1 or y belongs to array 2. Return the length of the longest common prefix among all pairs. If no common prefix exists, return 0. So all pairs, right? So basically just the longest common prefix. Well, you turn them into strings, right? So we just need to find the longest common prefix in both strings. And let's say I build a try for one of the arrays, okay? And then I traverse this for each one. I'll go through them one by one. Right, for each one of them, I go through them one by one and then match, 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 match. The first one that does not match will be, yeah, I think that's probably gonna work. So we're gonna try it. Use a try. Okay, so in the same thing, say class try node. Yeah, it is word. Yeah, it's fine. We can do like boolean is word. And map character try node children. Okay, and then what we're gonna do is array 1, right? For int a of array 1 string s shall equal to string value of a. Okay, so now we have s, and then we're gonna say try node node equal to root for char c of s dot to char array node dot children dot put if absent c new try node. node equal node.children.get c. Okay, at the end, node.isWord true. Okay, so then we get that, and then res equal to 0 for int a of array 2, string as string, the value of a. Now say try node equal to root char c of s.2 char array. Okay, and then int count is 0. Right. If node.children dot contains key c, node equal to node.children.get c count plus plus. Right, until it fail. Until it fail, and it gets out. Now we get the longest prefix, and we can do res equal to math.maximum, res and count. Right, and at the end I will return res. Three, 0, 4, 3. What do we call this? Use try. Create a try for one of the arrays, and use the other array to match the try, and keep count of the matching prefixes. Where m is the total number of characters in array 1, and n is the total number of characters in array 2. Okay, let's see if this one works. Ah, looks good. Submit it. That was bad. Huh. How? Oh, I need to break, right? If it doesn't contain. Oh, shoot. My bad. This was an error. Oh. That was an error. That's not too big an error. I didn't pay attention. Yeah, so once you finish, once you have a mismatch, you should just break out. Alright, it was not very fast. Let's see what's the solution. Hash table. Try. How would you do hash table? Let's see, hash set. Build all possible prefixes. And then hash table. Yeah, let's just do try. It's fine. We got this. Okay, so this is done. We have some time left, so we can try doing this one again. Okay, so again, the idea of what I had that day, it times out, right? It times out, which means I think this one is not going to work. We can't just go through everything in one. What we need is using the count to get closer and closer, right? Because we know when we count, we say start with 1, right? We start with 1, and then we do 1, and then 1, 0. Yeah, because 1, 0 contains, every 1 contains like 1, 10, 100. And then every time we check, we will check the thing, right? So we go, 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 go. Keep going. If it's smaller, then we do this. And also we check the count, right? If the count is larger than k, so after something, now we have a whatever prefix, right? And then a count is larger than k. If the count is larger than k, then we need to, let's say if we say start from 1, 0, 0, right? We're 1, 0, 0, and then we're gonna go to 199, and then the count is larger than k, so which means it's inside this range. So we shall start with what? Yeah, because we say 1, 0, 0 to the end is too much, so it will be 1, 0, 1. Yeah, it's we have, let's say this one 2, right? And now we keep going 2, 0, 0, 2, 0, 0, 0. Doesn't matter. If we say we have found, it's from 2, 1, 2, 3, 4, 5, all the way to 1, 2, 3, 4, 5. It's in between. Next, what do we do? Now we need to know because these are in order. Can we just do it immediately, directly from here? No, we cannot. Because we'll go back to the previous. So now it's gonna be, it's essentially is from 1. You go again, right? From 1 to, yeah, you start again. So we know just first digit is 2. Now you keep going 1, 2, 3, 1, 10, 100 until you'll get to some position, right? And then you will know it's gonna be the starting is gonna be like what we say 1, 0, 0 to 1, 9, 9, 9, right? So you know now that it's going to be 1. So the position is gonna be 0, 1, 2, 3. It's gonna be 2, 0, 1, something, something, something. So now you do it again. You do it again. So that seems to be doable. So how would you do that? Yeah, we reset, right? We can always reset. Right, we'll reset. And I should start from 0. So it can be 0. I can do one more computation just to avoid the 0 situation. So when I do count, okay, so count basically we have the maximum and the number, the k, right? And then the goal is keep going, keep going, keep going. If it get out, if it get too big, then we will just, right, if it's still smaller, then we will simply update to 2. And eventually we'll get current. Maybe. So what I think is get prefix. Okay, then we say digit is gonna be 1, count is 0. Right, digit is 1, count is 0. Then while count is smaller than k. Okay, and then while d, we also have multiplier. Basically, we say and be 10, and then 10 plus current count. Total, yeah, this is a count. So d plus count minus 1, right? D plus count minus 1. Or, yeah, d plus count minus 1 is smaller than n. D times equal to 10, count times equal to 10. Alright, so we start from, and then total plus equal to count. So while this we probably end count is smaller than k, right? No, not count, total. Alright, total plus equal to d times equal to count times equal to, right? And then we'll go for the next one. Voila. Okay, when it gets out, if it's too big, which means we depend, right? If total is still smaller than k, which means we handle everything, then oof. Okay, dd equal to d. Then d plus equal 1. Do it again. Yeah, we basically just tried everything. If it's too big, come out. If it's not too big, it's because the total, well, total, then that can also be too big, right? So it depends. What if dd times 10 is already too big? Yeah, what if dd times 10 is already too big? If dd times 10 is already too big, We need to handle the k. We need to update the k. Right, so when it comes out, okay, if total is smaller than k, which means dd plus this, okay, so if that's the case, if total is smaller than k, okay, which means we haven't reached there, but it's getting too big, so we need to go for 2. We need to check. We can say if dd is larger or equal to n, which means the start is larger or equal to n, but the end is bigger. Yeah, we probably should say smaller or equal to. Right? So I say if the start is larger or equal to n, but the end is too big. So we're going to update k. So k shall equal to k minus total. Is that right? Not necessarily. Because we say dd is larger or equal to 10, right? dd is, if the start is already, hold on, no, that's not what I want. We say if the start is smaller or equal to, right? But the end, the start is smaller or equal to, but the end is too big, right? The end is too big. So what I have is no, I don't think this will work. So how many is in between? Oh, it doesn't matter. Screw it. Let's just read the solution. I feel the way I'm thinking is still not right. Alright, so it's prefix tree. So you just traverse this? So you visit, and then you visit you visit this, then you do this, you visit, and then you visit, and then you visit, and then you visit all the children, then you visit the next one. Mm-hmm. Hold on. So what we're saying is, how do you compute how many numbers exist in the subtree rooted by defining a helper function count steps? Which counts? I think it's the same idea, right? But this is probably has a better implementation. A number between two prefixes, current and a current plus one. Yes. We're going to count how many is in between. How do I do the count? Well, the current level, it's just the same as this. It's the count, right? So given the current number, current prefix, tell me the total number of count. How many is in this? So I go, yeah, it is to count. Hold on. Let's redo this. Just count. Count the total number of nodes in the subtree rooted at pre. Such that all the nodes are no larger than n. I think this is the same as what we have. Right, so we have a tree, have a total. Right, so we can do same thing, d plus count smaller equal to n. Right, d equal to pre, and we'll count pre itself. Well, look great. We'll count it itself, and then we do this, and then d will increment by 10, right? And count to increment by 10. So we blah blah blah, we keep doing this, right? We keep doing this until the number is bigger than n, right? Until the number bigger than n. And then we need to know the total number, right? Know the total number under here. Well, we probably once it's smaller, once it's bigger than n, right? Then it depends. We want a count. That's what we want. We want a total count. That's just total, right? Or if the start is small but the end is bigger, that means it's just in between. No, we can do that. It's just right, so we say if d is smaller or equal to n, then we shall return total plus n minus d, right? Because total is the previous, and now we multiply by 10, right? But this gets also total should be plus 1 probably, because I didn't include everything. Otherwise, if d is larger than n, then just return total. So this is the count. Okay, I think we'll just stop right here. 36 minutes. We'll call it a day. I'll keep working on this tomorrow.